the time is whatever given. So in this semester, particularly I will take XY and Dr. Moshmi Shah will take Z, but since we share mode will conduct the class, so I will take all these section together, and sometimes she also takes some topics all that together as it is done in digital logic design. Okay. So today needs some interaction because whether everything is received by you or not, I need response. So you know the assessment procedures. Again, it is a midterm, end term, and classes assessment, and this time some assignment and attendance as some carry marks. Okay, so classes assignment, it will be like not in digital logic design. Here will be some case study or some design you have to implement. And for the syllabus, you will find that first section is the introductions. Okay, and introduction fully, we will discuss the issue of the functional components of the computer. I think up to digital logic design, you have studied so far the purpose of that is called, I think, did you study sequential logic circuit?
Yes, sir.
Okay, so already you have studied sequential logic circuit. Now you can make any at least automatic system which the state diagram is quite known to you. So here it may happen that I will give the state diagram and you have to implement the computer also. So this is the first part is the introduction. Here we will declare that different functional components of the computer as well as the how the performance of the computer will be evaluated. Then second part, particularly the instruction, representation of instruction. The different computer architecture, whatever we know in the market is available, and fully the classified the based on the instruction set architecture. So here we will study the instruction set architecture and fully find the addressing modes. Though we does not, that means we don't have any separate classes for microprocessor or microsystems. So what happened that in this semester, we will study microprocessors, 8085 register instruction set architecture in the representation of instruction classes. That is the one part. Second, we will go for the processing unit. That is the organization of the processors, registers, ALU, control unit, data path, and control unit, control path design. And finally, we will design the different types of microcontroller unit. The controller unit using hardware control unit and microprogram control unit. So these are the processing unit. After that, very interesting chapter, that the memory system, and finally we'll go for the input output system. So if you see the computer architecture, you will find that basic input output is the media or interface through which interact with the computer. This is the first system. And second part is that the memory one, where you store the information, and which is the directly relies with the stored program concept. And finally the processing part. So these are the all functionality we'll cover. And another chapter that I have not mentioned that is the computer arithmetic. It's a separate chapter, and fully there we'll understand different arithmetic logic circuit whatever generated so far by using some different algorithm. Among the most famous algorithm, the Booth's algorithm, we will study so far. This is the textbooks. Generally we will follow computer organization, Hemacher Jackie, generally the J-A-K with the last name. Is it visible to you, Hemacher Jackie?
Yes, sir.
Yes, sir.
This is Jackie. This is the name is the Jackie. Actually, this is the Safar Jackie. So we call it the Hemacher Jackie. So this book is our textbook. Most of the portion will cover from the textbooks. Publisher is a McGraw-Hill. And another part is the computer organization design. Actually, I will discuss most of the topics from here. That is the Patterson and Hennessy. So David A. Patterson, Hennessy, this the books is available. Two books are there. One is for computer architecture, and another is the computer organization design. You remember this topic, hardware software interface. This is the title, subtitle, you mark it. Because two books are available in the market. One is computer architecture, but the hardware software co-interface is not there. So our book is the textbooks, computer organization design, the hardware software interface. Remember this part, David A. Peterson. Okay. And some another books we will follow, particularly in the during the memory structure. I will focus modern computer architecture, Rafiquz Zaman and Chandra. This part also for the memory very interesting. And when I will discuss the pipelining and the other instruction, then we'll go for the JP Hayes and other books. And also for instructions architecture and control unit design, you can follow computer organization design, Pipal Chaudhary. All these books are available in the library as well as the market. So in online, you can go for the ebooks also. These ebooks are found there. Books, related books, any query?
Sir, could we get a list of this, sir? Because in case we need to get them, sir, if we could get the list of these as a PDF or something like that. Is it
What
in
are
the syllabus? Sir, is the list of these books in the syllabus booklet itself, or can we do we have to screenshot this and take it, sir? It would be very helpful if you could do that.
No, this slide I will give in the your module also. Don't worry.
Okay, okay. Okay, thank you, sir. Thank you, sir.
Slide will be given in the module because today I will create the module for CSC 401. As soon as I'll create the CSC 401 module, everything as it is today digital logic, everything will be uploaded there also. Okay. Now let's start a little bit discussion with the module 1. Generally, if you notice the architecture part, our first start, because lot of mathematical competition as well as the circuit design will happen, and we will start through this. We'll study this using our basic module. That means overview of the computer architecture and organization. We'll follow this paradigm in the book module Pipal Chaudhary. Okay, so initially you will find one term was the computer organization and another is the computer architecture. So what we are going to study is architecture come first or organization come first? There is a question for among all of us. So let's discuss this issue that computer organization or architecture. When you want to purchase a computer, suppose you would like to design a new computer, then what will be the steps you will follow? Just discussion today. You just tell me. Suppose you would like to purchase a computer for yourself, or maybe you are recommending the computer from others. Then what will be your criteria to choose the computer?
Sir, a CPU, sir, processing unit, input devices, output devices.
You will choose input device.
Yes, sir.
And
So, for example, mouses, keyboards, that stuff.
dear student, you should be aware that if you are using online classes, any unexpected noise will be reflected in the classes. I directly fire from the student from entire semester from my class. I am not like another madam or teacher that you will get disturbance and I will tolerate. If someone responding, please listen. Unable to listen, you sleep and go a happy, nice dream. I have no problem because I am online classes. I am not checking whether you are live or dead. Very wrong, unparliamentary term I'm using, I know, but I'm using because you people are doing these things in the classes. Completely intolerable. I am doing the classes and you are people making the some semester making sound. Because when you are making sound, this is visible to me. Don't worry. My memory is very strong. I remember for your entire life. Okay, now come to the point. Prajuta, what are you telling? Tell me.
Sir, I think that was my fan only, sir. My fan is actually a bit rusty, sir. That's why I switched off the fan, sir.
First tell me, when you are going to purchase a computer, what are the things you will first choose?
Sir, input devices, output devices.
Input, output device. Okay. Vishal Mahavar. Today, since the discussion live on your video, Vishal Mahavar.
Yep.
Okay. Tell me what the parameter you choose for selected purchasing a computer.
Sir, for purchasing a computer, we can choose CPU. We can choose the CPU, like what kind of processor we
Are
need.
you
We
doing
can
the
choose
classes on laptop or mobile?
laptop, sir.
Laptop. Then you have purchased the laptop. Something you choose in the laptop, or you went to the market and give me the laptop you came.
No, sir. We will first decide about like processor we need, the RAM, storage, internal memory storage. These are some
How do
factors
you,
that
how do you choose the RAM? Particularly, tell me how do you choose the RAM part?
preferably, sir, like uh, the size of storage in the RAM, for example, 4 GB or 8 GB RAM.
That means you are not sure that how much RAM is required for you, and you are going to the market. You are just bargaining. Is it not like that?
Uh, Sir, it depends on the
Myth
use
is that
actually.
common myth is that if I have a maximum RAM size, it will be good for me. Is it a common myth?
Yes, sir, it's a common myth.
Sir, it depends on the use actually.
RAM is more, so speed will be high. Is it?
No, sir, that
Uh,
depends on
Not
the
just RAM, sir,
memory
also
configuration.
internal
Okay.
memory.
Abhishek, I got your point. I would like to go Abhishek Basu. Okay, you
Sir,
now
can
go
I?
for switch off your video. Abhishek Basu. Live on your video. Okay. Tell me, what is your opinion to choose? GPU also. For what purpose? Gaming. Gaming. Not at all. I am not getting a proper answer. Still wait. I am waiting. Saurabh Kumar Roy, any idea?
Sir, storage SSD, not HDD.
Not visible to me.
Okay.
Today's class.
Yes,
Master
yes,
maybe.
sir.
Okay. Tell me.
I will go for the storage type of SSD.
Storage type SSD. Any reason for choosing storage SSD?
Yeah, sir, it's faster. As a, I have listened from uh, everyone and studied somewhere on net.
That means somewhere you have studied SSD is good.
Yes, sir. Then HDD as
Not
compared.
a not hard disk. Okay. Okay. Abha Jha. Okay. I am not getting your answer also properly because that is just like class 6. Abha Jha. Abha Jha. Absent. No problem. Absent or present? Abha Jha present. I am not getting you properly.
Hello.
Yes. Switch on your video if possible.
Yes, sir.
You are using mobile, I think.
Yes, sir.
Okay, that's why the video is not properly. No issue. Okay, then can you tell me what are the parameters you have considered during purchasing a computer?
Sir, storage mostly, and
Sure. Storage. Okay, switch on our video. I understand. Switch off your video. So it is a came to know that fact. Someone SSD, someone input output device, someone choosing the storage. But is this the sufficient criteria to choose? All the answer giving the question that you people are studying in class 5. Okay. So again, I will start from class 5 session. Okay. First, go to your goal. Just like for a programming purpose, you need some operating system. Am I correct or wrong?
Yes.
Yes, sir.
Okay. So you need an operating system. Then you must aware that operating system must have size. Whatever the instruction side of the operating system indicates that the number of address bit actually it can address for the particular instruction to be fetched from the memory to CPU. Based on this criteria, you found that, remember the point, a 32-bit OS and 64-bit OS. What does it mean actually? A 32-bit OS and one is 64-bit OS. What does it mean? Can you tell me?
64-bit can calculate 64-bit.
64 bit calculate.
I think it depends on cache file.
Cache file. What is cache? Money.
No, cache file, CSC.
CHE. Okay. What does it mean?
CSC.
CSC. Okay. What does mean this?
Means
What does it mean, cache? Not clear.
It's a temporary memory, sir. Cache is a temporary memory.
Temporary memory. Very good. The memory temporary, that means sometime it will stay in the computer, sometime it will be not in the computer. Are you telling these things?
No, sir.
No, sir. Then what are you telling? I am not. Can you clarify it? Konkon Pramanik, very good idea. Temporal. Okay. Not clear, anyone? See.
Due to the very fast memory, but
so I think it stores data so that in future the data can be fast.
2 to the power 64. The value you can imagine 2 to the power 64?
No.
No. Okay. 2 to the power 5 is 32 bit. If I say 2 to the power 5, that is how much of bit length? 32 bit?
yes, sir.
64 bit OS means it has the capability to address from 0 to 2 to the power 64. The number of location actually it can address. Am I correct this point? It means that the size of the memory location can be accessed. See, earlier days it is found the RAM was only KB. Then after MB, now it is GB. And now you are purchasing 8 GB. What is mean 8 GB RAM? Then you may, what is the total number of address will be there in the 8 GB? If you remember, you will find that 8 GB it will be more than 2 to the power. GB means 2 to the power 30. Am I correct? Am I correct or wrong?
Yes, sir.
So 2 to the power 30 is the capability you can access through the RAM. But your CPU has the capability to access 2 to the power 64 bit. It means that all the instruction of the operating system may not be loaded in the cache, I mean RAM. So today, our first discussion will start from the functional unit of the purpose. So I would like to see a figure first. We first see the person's image, then I'll come. The image is available to you?
Yes, sir.
One scientist. Okay. So every course will be started with a scientist who has created the actually code. Can you tell me the name of the fellow? It's the 1940s figure. Anyone can recognize him?
Turing?
Charles Babbage.
Yes. Tell me.
Sir, Von Neumann, sir, Von Neumann.
Who said this, Von Neumann?
Sir, me, sir.
Very good. Ashutosh Thakur. Though I don't know how guessed.
No, sir.
You guessed correctly. Very.
No, sir, I didn't say that.
Sir, me,
What?
sir, Uchishman.
Is a Von Neumann, the pioneer of the modern digital computer, you can say. In class 5, whenever you will study who is the father of the computer, you say the Charles Babbage. Am I correct or wrong?
Yes, sir.
The modern digital computer, what we are using now, modern digital computer, I am telling. So come to the point, the modern digital computer, what is the actual principle that he has demonstrated, and that is the Von Neumann. So from today's class, you just remember one point in your mind that Von Neumann is the actually the whatever the creator or the developer for the modern digital, whatever laptop or computer we are using now. The person's name is what?
Von Neumann.
Ah.
Von Neumann.
Just remember this name, because I know at the final year your brain will be completely collapsed and the name will be comes out. But at least try to remember the von Neumann is the person who has first given the concept of the stored program concept. What is stored program concept? That means before executing any instruction, any data, whatever is required, it should be first loaded to the memory. Where it should be loaded? It should be loaded into the memory. Am I correct or point? First try to understand. It should be first loaded to the memory. Now what is the memory in terms of my point of view? Any idea of the memory?
Storage unit.
CPU, sorry, RAM, ROM, hard disk, SSD. Tell me.
Hard disk and SSD. Oh, sorry, RAM. Sorry.
RAM. Anything else? See, if you discuss these topics, have some critical concept there, how computer has evolved. Because sometimes why the subject name is computer organization architecture. For my point of view, it is same. See, initially concept was this is the CPU. So I am telling the CPU, here it is means my processor. Clear? Now you will find that processor will access some memory. I am writing it is a MM. There is a small memory, I am writing it as CM. And it will be accessed by the CPU and CM or main memory concept like in this way. And main memory is connected to the bunch of other memories, CD-ROM, all these things. But if you notice that in CPU has some internal registers, that is also memory, high-speed memory, but the very less size, inbuilt. Nowadays, CPU cache also divided two parts. One cache will be embedded with the CPU itself, another cache is as it is outside, is it present. So that is L2 and that is the L1. These are two different. Forget about this part. But you just notice clearly that CPU always connected on the main memory as well as cache memory. There is no direct connection between CPU to other memory, other than pen drive, flash drive, SSD, or maybe your hard disk. CPU is not directly connected. So whenever I will point any memory, then which memory actually I am pointing? From today, you just remember, I am pointing the main memory. Am I correct this point?
Okay, sir.
The figure, whatever I have shown, is visible to you?
Yes, sir.
Actually, I will discuss through our Wacom from Monday. Everything I will draw in the Wacom so that it will be very clearly. Today, just initial classes, I am doing this like in this way. So, in the CPU, first you will find that CPU first access main memory. Wherever, because cache does not contain all the data whichever is available now at this moment. Cache only will be accessed as some principle. Detail I will go for more detail in the chapter, on the cache chapter, but remember that cache was introduced for locality of reference. Is another phenomena of the computer. Very interesting phenomena. I think, suppose you have a friend, XYZ some name, and every day in the evening you found your friend is there in your jobs. You have a fantastic jobs is there in front of the NIT Durgapur.
Yes, sir.
Very, you are
Yes, sir.
missing that jobs.
Yes, sir. Memorable place.
Yeah, I am also very passionate to see that my students are enjoying the jobs. And when I go their side, I see all the students are enjoying. So it is a very nice moment for all the students. Okay, now, and every day Sunday you found one person is there. Now, one day you went there and the person was not there, suppose. Then what will be your next step to find out the person? What will be next step? You went in front of the jobs and found that the person, your friend is not there. Then, but it's the urgent need that you have to get, you have to meet with your friend, then what will be next step? What will you do now? A
We
Joop
will
name XYZ.
To
Okay.
to make a call to him or her.
To make a call. But I am asking that it is a physical meet. Suppose there is no mobile.
we will ask the Jup member, have you seen him today or not?
No, common sense. Just apply common sense. Your common sense says that whatever I feel that,
Search for him.
yes, search.
I should remember his last position.
So where you will search? Your first step, you have to search. Where you will, from which point you will start searching?
Rantika.
Hostel maybe, sir.
Yeah. Oh, very good. Another point. Is it not possible that you know you are meeting on the Jobs XYZ regularly? When he is not available XYZ, you will not search his nearby Jobs available or not. Maybe due today he did not get any place there, so he went another Jobs maybe nearby of the Jobs. The human tenacity is that first of all you will go for the nearby location of that common places where you did get the person. Am I correct or wrong? Am I correctly explain
Yes,
this
sir.
point to you or not? This is the first tenacity. You know, at 1:30, Bivasar has a class, and you know he will be room number 205. So first you will go to the 205. If your friend is not available 205, you will search that whether sir is taking the classes from another class nearby it or not. Maybe due to some problem, may take other classes also. Am I correct or wrong? So this is the common fundamental principle that nearby location will be searched. Am I correct or wrong? Or you will go Bivasar quarter, or you will go to the hostel that I am teaching in the class online or not. What will be your first probable symptoms?
Next place.
Yeah, but this is the first concept, that the next nearby location. Remember this point, whatever I have told. This will give the idea of your locality reference. This is the first one. Another point is that every day, you know, my class is going on 1:30 to 2:30, but every day 1:30 to 2:30, you need 1 glass of water. During my class session, it is some physical phenomenon happen. Then again every day you will come to the class, and 1:30 or 2:30 you will go to the hostel, take a glass of water, then again come to the class, or you will carry a bottle of water with you, and during the time you will access it. What will be your opinion?
Second one.
Which one?
Second one.
Second
Drinking
one.
the
Then
water.
most frequently asked or most frequently tasked, which is rigorously be accessed by you, should be kept within very near to you, close to you, or maybe kept in your bag, so that in the time need of hour you can directly access it. Am I correct or wrong? I need your response. I am not teaching any bluffer number. Okay. Very intellectual persons
Yes,
are
sir.
there who are JIT techniques. Okay. Are you sleeping?
No, sir.
No,
Which?
sir. No
No, sir.
sleeping, sir. We didn't have lunch.
Okay. Mostly sleeping, na? Okay, very good. Actually, after 1:30 the sleeping time, I don't know why this computer, the most toughest subject of this semester is given during this subject. Hey, toughest I am declaring, not official declaration from the college. Don't take it. Aditya Gupta,
Yes, sir.
any understanding these two concepts? Is it clear to you?
Yes, sir.
Then first one I call as a special locality reference. That means whenever a data or instruction from the memory you are accessing and you need the second instruction, so the CPU first try to access the nearby location of it. Am I correct this point? If it is not found, then automatically sequentially what happened? Cache was first introduced to solve this purpose. It means that whenever you are accessing a bunch of data, or maybe it happened that particularly gaming, it is found some repetitive tasks are there. Maybe firing of some bullets, or maybe firing some in the playing of, you are in a PUBG or something, you are playing so many firing, some repeated tasks are there, which requires some set of instructions. So what happened there, sometimes it happened that in a program also, if you are doing some array programming also, you may do some array program. What happened that during the array program also, set of data which is required for executing some instruction operation, it can be consecutive memory. Just 1 minute. So it may happen that particularly some data which is required to be accessed, it should be fetched. So if I say from very beginning I'm starting, first switch on your computer. That is called booting process. Okay. Initially during the booting process, no data is there in the cache, no data is there in the RAM. Clearly try to understand this thing. First booting operation started, then a bootstrap program will be loaded, and bootstrap program is nothing but not loaded actually from the ROM it is executing, which is called BIOS. So from basic output input system, everything will be checked, and when it is found that all the necessary devices required to perform an execution of the computer is okay, now computer starts loading the OS. Entire OS generally not loaded. Again from the basic primary functionality of the OS will be loaded. OS what is nothing but a program, and which is a system program where lots of instructions are there. Among them, those instructions which is required will be loaded in the computer. Very essential required, maybe for keyboard operation, mouse operation, maybe some display operation. Only those instructions will be primarily loaded to the main memory from the secondary memory. And secondary memory directly connected, maybe network operating system, maybe by pen drive, anywhere maybe, but it should be loaded to the primary memory. And as continuation and the process goes on, the number of instructions be required will be loaded automatically to the main memory itself. Am I correct this point? So if required, maybe you are trying to play a movie song, that time the instruction required to play the movie song, that will be loaded to the main memory, and some part will be later, because main memory size is 8 GB, and you are now dealing with the 2 to the power 64, and now your RAM capacity 2 to the power 30. So using 2 to the power 30 memory, actually you are utilizing 2 to the power 64 capability memory. So all the contents of the memory may not be available to the RAM. So only the fraction or some parts of the memory will be loaded. Now which parts will be loaded in the OS class, will understand what are the parts to be loaded. For time being, you just remember that this parts will be loaded. Is it clear? Now, so question may come, whenever a data or instruction is found, generally we call in paging scheme, it is called a page. Whenever any data instruction is found on the memory, I will say it's a hit. This is the term you will find gradually. When it is not available, I will call it a miss. Can you tell me in which situation every time I will get a compulsory miss in the cache? Compulsory miss in the cache. Any situation or Chishman?
Sir, could you please repeat the question once?
What?
Sir, could you please repeat the question once?
My question is that a situation will be there where I will get a compulsory miss in the memory, particularly I am telling the cache memory. A compulsory miss will happen. When?
Sir, if the cache is very small.
Yeah, cache is very small, I know. Main memory also small compared to the secondary memory.
So if our task is, if our task space is more than the cache, then it will be a miss. I don't know. Sure.
Just remember in the booting process, what happens?
Sir, when it's brought in the first time, sir, when it's
whenever
when it's booted for the when it's booted for the first time, sir, in that case,
yeah,
like when we just started off.
First time access of the cache, because now come to the point, I found that when operating system loaded, the operating system loaded the main memory. So you just remember that cache memory always contain those content which are available in the main memory itself. Remember this point. So main memory, cache memory is a subset of your main memory. Clear? Cache contains some pages, which page is already there in the main memory. So what is the purpose of the main cache memory? Because main memory contains all those pages. Purpose is that already I mentioned two phenomena. One phenomena, one of our friends was there and I try to access my nearby friends, one of the concept. Another is that frequently accessing part which I can store in a particular place and I will access this part regularly. In this means the principle of locality references. To execute the task very efficiently, speedily, every time I have to go for main memory and search the data, this is very bad. The speed of the cache memory is very, very faster than the main memory, and it is very closely associated with the speed of the CPU. You will find a huge speed gap between main memory and between the CPU due to the different technology. So our target that at least cache memory speed should match very close to the CPU. So if I consider the speed, you will find that the register, CPU register is very close to the CPU speed, then cache, then main memory, then secondary. So secondary is very slower. Nowadays, SSD is coming is a good option of secondary memory, which have a good speed like our RAM also. So very close to RAM. So then as a semiconductor based solid state device. So also it is a good choice for another comparing our magnetic hard disk. Now come to the point, whenever this operating system is loaded in the main memory, there is no content in the cache. Cache will be starts loaded with the first access of the pages, and it is found that gradually the pages which is required to be accessed frequently based on the requirement of the program, only those pages will be available in the caches, not all the pages. And sometime it is found when you are accessing the block of data, so the nearby data also should be loaded to the cache so that whenever searching you are doing x plus 1 can be accessed also during that time. So these are the two possibilities happen in the cache principle they are discussed. Now, in the introduction of the computer organization architecture, remember that when you are going to purchase a computer, your first criteria could be what is the size of the hard disk, what is the size of the your bus size, what is the bus capability, what is the clock speed. All these things parameter will specify the requirement of a particular purpose. See, if I would like to pay only for documenter word processing tasks, I am doing only word processing tasks, not more than this. That time, I think I does not require more than all different all softwares. Only word processing MS Office is sufficient. So very less capable hardware is sufficient for me to execute the program. So that is the main thing. But when you are playing a game, you need complex GPU or CPU type architecture. That is the another point. So the requirement will specify the architecture what is required. Now come to the point architecture. If you feel that a architecture specifies to make the room airy, a window and a door is minimum requirement for the architecture. Architecture specifies a 3 by 3 size window and a 1 2 by 4 size 4 by or 6 by 2 size in the door is required. Now imagine your door is placed in the Windows position and Windows position the door is placed. Is it will be a viable solution for me?
Sir, repeat the statement once more, sir.
All of you are after lunch really very critical. I am telling that architecture specifies that I need a one window and one door. One door and one window is my requirement. Architecture specifies that to make it airy and the ample light will be there in the room. You have to provide one door and one window. Is it clear?
Yes, sir.
Now, in my chamber, whatever I now belongs to that from where I'm taking the classes, suppose my window is replaced with the door and my door is replaced with the window, just like I have fitted like in this way. So it will be suitable that when I come to the corridor in the classroom, I have to jump to the window and enter the classroom. I enter my chamber. So anyhow, just placing the window and placing the door will be sufficient.
No, sir.
No. That means it should be connected properly.
Yes, sir.
So you will find that whenever you are purchasing a computer, You may specify the architectural part. That means I require 2 GB, I require 4 GB, I need this clock speed, I need this data. But when a computer is manufactured, they are connecting following some principle. What is the principle? One figure just I given. CPU cannot be connected directly to the hard disk because due to the speed mismatch, CPU need a high speed memory, so CPU will be connected to the main memory. Am I correct or wrong?
Yes, sir.
So this the connection, that means how all the device will be interconnected each other to get a proper functional unit that will give the proper concept of the organization. Am I correct at this point? Now it is clear which part is architecture, which part is organization.
Yes, sir.
Now again more details. Suppose you are designing a computer which will do only addition of two numbers. Only one instruction add. Only one instruction. What is the instruction? Add. You need only one instruction, that is add. Am I correct? Is it clear or not?
Yes, sir.
And you are making some register because two number you have to store. So you need to register A, another register is B. Am I correct? Two register A and B. So
Yes, sir.
you are making a CPU where only you have to store one instruction and you need to register to data store, or maybe one memory where I can store two data. Nothing more required. So it is a single instruction architecture I am telling. So single instruction processor I am making. Only one instruction is there. That is single instruction processor. Am I correct? So in single instruction processor, only one instruction will be executed. So the number of memory is very less. Only two location, and also to store a CPU. Suppose my instruction and data I am storing separately. Otherwise, in a single memory also I am storing all this. So three location is sufficient. The capability of the single instruction processor and how it will be connected is clear. Now I suppose I have a 5 instruction. So only one 5 instructions. So one register is not sufficient to store 5 instructions. At least I need 5 instructions to be stored. An instruction nothing but a combination of the bit. So you need to do the 3 location of memory. That means 3 bit size memory location required. 3 bit can store at least 5 locations. Am I correct or wrong? 2 to the 3 is 8 location. 2 to the 3 bit memory, it will be 8 location.
Yes, sir.
Yes, sir.
Then using 8 location, it can store 5. So the number of registers will increase. See, based on the instruction set, the now architecture differ. Whereas in the one instruction set, only you require only 1 register and 2 register. Now your register is more compared in the earlier cases. So based in the number of instructions, architecture will differ. Am I correct at this point? But the joining of the computers, that means you need CPU, you need register, you need memory, and how they will be connected, that completely based upon the principles of the store program concept, whatever I will say, organization. So before the purchasing a computer, you should know the architecture of the computer. Whether I need some gaming protocol, whether I need some technical competition statistical workstation. But because based on the architecture also, you will find that the workstation, desktop, laptop, and earlier days server, the purpose also differ. They are different on the different application. And different application, the connection between the layout, the size of the bit, processor size, everything differs. It doesn't mean that you are doing some word processing system and I will give you a workstation, which is very costly. And that is not a viable economical solution for you. So that's why it is a very important parameter. First you go for the architecture, then you go for the organization. Though we will discuss in the classes organization first and then architecture. Okay. So that overview of the computer architecture organization will discuss. Then you will find there data representation arithmetic algorithm. This is our module 2. In this chapter, we will learn different binary representation of the data. Already we have studied so far, but here we will study the computer arithmetic, how actually registers are utilized properly to get a multiplier result or to get the data. Or again, IEEE 754 floating point number representation, that is standardized happen. Module 3 will study complete process organization and architecture. That is the what is RISC or 6. Remember, RISC is reduced instruction set computer, and C is the complex instruction set computer. This C instruction set, IS means instruction set, and particularly instruction set will differ you to different type of architecture. So it is very important for you to understand the instruction set architecture. Then we will go for the memory organization, and now you will find that what actually the storage module record, because every time I told that to execute an instruction, I have to store all the things in the memory first. So that is the memory organization study. Then you will go for the IO organization. Though these are the 5 modules gradually we will study, and mostly I will focus number 1, 4, 5. Madam will maybe teach 2 or 3. Okay. So now I will start very beginning from 1 to 4. I will discuss 1. Then I will directly go fast 4 chapter, that memory organization. Then rest of the part I will discuss. Now, architecture is those attributes visible to the programmers. So what is the visible to the programmers that I told? Instruction set, number of bits used for the data representation, IO mechanism, and addressing techniques. So a question is there a multiply instructions are there? Is possible. Multiple instruction also possible. Add, sub, mult, that means multiplication and division, such type of multiple instructions are possible. So architecture is those attributes are visible. And the organization part is how features are implemented. That means control signals, interfaces, the memory how will be connected. These are the requirements for the organization. Is there a hardware multiply unit, or is it done by a repeated addition? That means if you go a question for this one, you will get the answer. This of the question is there. Is there a multiply unit, or is it done by repeated addition? That means in the organization procedure, you can use 5 multiplier units simultaneously to get 5 multiplication, or you can use 1 multiplier unit repeated using some looping structure also to get the 5-bit multiplication. So this is the organization procedure. That means in the ALU it is bit sliced or it is a timestamp based. So based on that you can do the multiplication. So there is the full organization that a multiplier will be there or 5 multiplier will be there, and all the multipliers simultaneously used, or a 1 multiplier will be repeatedly used for 5 multiplication. In the organization point of view, but in the architecture point of view, is there a multiply instruction? That means to multiplication, doing multiplication, a multiplication instruction set will be there in the architecture, or what will be the size of the multiplier that time I can specify. But the how multiplier will be utilized, that is not specified in the architecture. So am I clear the point? Which part is architecture and which part is organization?
Yes, sir.
Just for the sake of the knowledge, you remember that I can specify the size of the multiplier. But how the multiplier will be connected to the CPU, or how it will be utilized in a repetitive task way or in a parallel task way, that will be defined by the organization of the computer. So just a simple example, maybe adder. You are doing 4-bit addition. A simple adder can be used repeatedly using looping concept 4 times, or maybe 4 adder block will be there to add simultaneously. Both is possible. Otherwise, it may happen in architecture point of view, I will ask to get addition whether add instruction is there or not my instruction set, or you can say in another way, add instruction is supported by our architecture or not. That only specify the architecture and what will the adder size. But how adder will be utilized, that will be done by the organization. So in the purchasing part, I can say architecture come first, then organization. Is it clear? First architecture, you specify the architecture, then organize the computer, then it will get the functional unit. So the internal arrangement of computer, which includes the design of the processors, memory and input also, that gives the computer organization. But computer architecture describes the feature of the computer family. Maybe it is a spec architecture, MIPS architecture, or maybe some parallel computing. not the specific implementation, just like architecture of a house, that we mean a von Neumann architecture or something, I can say. A non-von Neumann, where no stored program concept are there. Our modern digital computer, all are von Neumann architecture follows. So your laptop is the von Neumann computer. So in laptop, if there is no RAM, there is no hard disk, you can't operate anything. You just remember. So that should give the idea that everything should be stored first before doing the execution. That's called stored program concept. In architecture part, I can say all Intel 8086 family.
Sir, could you go back to the architecture portion, sir? I missed out on the definition, sir. The architecture yeah, thank you, sir.
It's clear?
Okay, sir. Yes, sir. Yes, yes.
Here I mentioned notably the instruction set. Just in architecture part, in this class, actually I am not dealing with advanced computer architecture. In the UG level, you just follow the ISA part. All Intel 8086 American 86 family share the same basic architecture. Can you tell me why? First answer this question, then you'll understand what is actually organization and what is architecture.
86-bit, sir. 86-bit, sir. So
no,
all of them have.
You forget the bit. Forget the bit part. Whatever just now previously I explained. Follow this one. See, suppose 8086 and one is the another system. I follow the IBM 370 family. These are the two different family. These are the two different family. Someone follow Intel 86 architecture and someone follow IBM 370 family. The processor or maybe the design which is applicable for IBM 370 that does not follow the Intel 86 family. And also the architecture or system follow 86 family does not follow the IBM 370 family. Why? The difference between the instruction set. Maybe 8086 or maybe across 86 family, Intel family have 1000 instruction or IBM supports only maybe suppose 50 instruction or maybe 500 instruction support. So IBM which support only 500 instruction cannot operate in 1000 instruction, cannot be supported by him. Am I correct or wrong?
Yes, sir.
In a room, if you can place 5 tables, in that room you can't place more than 5 tables. This part is clear or not?
Yes, sir.
For instruction
Yes, sir.
set of view, we can be remembered that in particularly some architecture which support some instruction set, based on the instruction set all the hardware will be there. If instruction to the bar, suppose 10 instructions there, only 5 registers is sufficient, maybe 4, at least 4 registers is sufficient, which require only support 10 instruction. But if you require support 100 instruction, 4 registers will be supported. So based on the instruction also all the hardware, logic, unit, module, everything will differ. So they will not share. All the 86 families share same basic architecture, means they have the number of registers, the minimum part will be same. Maximum depends upon the architecture. So architecture and organization, sometimes it looks very same to you, but point of view clear that one is completely specify the number of instruction, number of the bits of the which is required to store the information, all these things. But how the internally it will be organized to get the better functional unit or better output or better performance, that fully depends upon the computer organization. Having same architecture, having same architecture and same hardware also, sometimes for poor organization may lead you better, may lead you poor performance of the computer. I will show you that just clock speed will be high, your device will be high performance, not at all. It's not at all. Suppose you are moving through a car from Ferrari. You are operating through Ferrari car and I am operating through a bus, big bus, Volvo bus. When speed will be requirement, you will be faster than me, you will reach a particular destination very fast. But when throughput is high, the maximum number of person will be reach particular destination. There will be large number of data to send particular destination. My performance will better than you. Am I correct or wrong?
Yes, sir.
Yes, sir.
So always high speed does not mean the performance will be better. Just remember that. Ferrari is more higher speed than bus also, but does not have the good throughput than whatever bus I have. A Ferrari need to be 4 times to be done, but a bus to be 1 time running sufficient. Though I have delayed, but my performance will be better. Again, where high-speed competition is required, my performance will be very poor because I am very slower. That time, Ferrari will be better. So like in this way, now you purchase a Ferrari, but the road is one way and one car only can go at a time through the road. That time, if before the Ferrari 5 cars are there, the performance of the Ferrari will be very poor, like me. True or false?
Yes, sir. True.
That time you need
True.
a road also, which a 4 lane and 4 car can simultaneously done. That time Ferrari can lead me and go better than me also. So like in this way, architecture will specify you the number of size, bit, or maybe the basic instructions in architecture, but your internal organization, that be 4 lane or 1 lane or 2 lane, or maybe the connection of the organization will give you the better performance. So both are correlated but distinct features. And in our class, we'll gradually study all this part. From tomorrow, that is from Monday 1:30, I will start from the computer level hierarchy. Okay, so this up to the today's class. Any question you can ask me now. Any question from your side? Or I understood that it is completely clearly understood by you. Okay. In my class, if you ask question, actually, you will be rewarded in your classes assessment, in your exam or something else. Question may be bogus for other friends. For any question, from my point of view, your question is valuable to me. Maybe bogus for you or maybe bogus for your friend, but very valuable for your me. So try to ask question. Maybe your question will give you a good impression in my classes and a good impression to me also. If you don't ask question, I will think that you don't understand anything. From the next class, prepare. Because if you don't ask question, I will ask question to you. And that time, if you are unable to answer, it will be a demerit for you. And I will count the demerits for each of you. And after counting 5 demerits points, you will not get EX in my subject. Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you for attending today's class. And from Monday, I will start the classes. Okay.
Thank you, sir. Thank you, sir.
Thank you, sir.
Question? No, that can leave.
Thank you, sir.
Thank you,
If you
sir.
don't have a question, please raise your hand. Otherwise, all of you can leave.